Okay guys, this is video 5. I'm going to be reviewing, finishing up here for the, not finishing up, but the next video, video 5 on reviewing for the final, using this practice final. So right now we're going to go to number 15A, solving square root inequalities. So in order to do 15A, it looks like there's a lot of steps here, step 1, 2, 3, and last step 4. But in reality, step 1 and 2 are solving, right? So step 1, isolate the radical, get the square root by itself on one side. So you want the square root by itself. You don't want this plus 7. So obviously we are going to subtract 7, and rewriting our whole radical inequality again, we get this. Of course, you bring that down. That canceled out right here. 13 take away 7, 6. Inequality is still there. Now, step 2, square root. Square both sides to get rid of the square root. So we're going to square this side and we're going to square that side. So we will have, let me move this up. We're going to have 3x plus 6 is greater than or equal to 36. So the next step would be to subtract 6 on both sides. And let me just draw it over here. Draw an arrow over here. So if I subtract 6 on both sides, I want to have 3x. I want to have greater than or equal to 36. Take away 6 is 30. Then after that, of course, solving that, we're going to divide by 3, divide by 3. We're going to get x is greater than or equal to 10. Okay, x is greater than or equal to 10. So that was step 1 and 2. If we look at step 3 and 4, step 3 says go back and set the inside of the square root to be greater than or equal to 0. Okay, so the thing is this inside value, the 3x plus 6, it has to be greater than or equal to 0. In other words, it can't be less than 0. Because if 3x plus 6 was less than 0, then you end up with a negative, which would make it imaginary, right? So we need to set 3x plus 6 to be greater than or equal to 0, and that's what I'm going to do right here in this area. So if I take this and write it right here, and I set it greater than or equal to 0, even if this were a less than or equal to 0, it still has to be greater than or equal to 0 because we're talking about the inside of the square root value has to be greater than or equal to 0. So anyways, if I solve it, if I were to subtract 6 on both sides, I'd get 3x is greater than or equal to negative 6. And of course, my final step, if I divided by 3, my answer would be x is greater than or equal to negative 2, because negative 6 divided by 3 would be negative 2. So we have these two answers right here. And then you got to go to a number line and either test your areas or see what the inequalities are. So let's go to a number line. Let's draw it blue. The 10 is obviously going to be on the positive side, and the negative 2 is going to be over here on the negative side. And of course, let's say 0 is right here. Anyhow, we need to test values, and you could test by either plugging into the original, or you could actually graph the inequalities and represent your overlap piece. So if you said x is greater than or equal to 10, it's that way, and x is greater than or equal to negative 2, it's also that way. So the overlap would be over here, and your answer would be only the inequality x is greater than or equal to 10. Now, let's say you actually wanted to test values. Okay, so you're going to have to test a value that's less than negative 2. So like, let's say negative 3, all right? Well, if you did plug in negative 3, 3 times negative 3 is negative 9, and negative 9 plus 6 is negative 3, but the square root of negative 3 is imaginary. So you can't, it doesn't work anymore. So obviously, over here, this side doesn't work. So now let's test a value that's between the negative 10 and the negative 2. Okay, so let's test 0, yeah? 0 is pretty easy to test. So if we plug in a 0 right here in our heads, we say 3 times 0 is 0, plus 6. That's the square root of 6. Now the square root of 6 has to be less than the square root of 9. In other words, it has to be less than 3, right? If you did it on a calculator, you could do the square root of 6, and you're going to get 2 point something, right? Anyways, 2 point something plus 7, that's 9 point something, and that's definitely not greater than or equal to 13. So the middle value also does not work, okay? Now, if you test any value that's greater than 10, it will work, all right? So like, let's say you did test the value, let's say 20, just for the heck of it. So I want to test the value 20. That's clearly on the right side of 10. So if I did plug in a 20 right there, 3 times 20 is 60. 60 plus 6 is 66. On a calculator, if you did the square root of 66, it would be about 8 point something. The reason why I say that, I don't even have a calculator, but I know that the square root of 64 is 8, so the square root of 66 has to be 8 point something. So 8 point something plus 7, that's 15 point something, which is definitely greater than 13. So as you can see over here on this area, it's a yes, it works. So it didn't work over here. Nope, didn't work. It didn't work right here in the middle. Nope. But over here it does. So that means that your inequality is x is greater than or equal to 10. So this one did not work. This is your only answer right there. Try this one. Okay, so we're going to add 4 to both sides. And of course right here it cancels out. We have that new inequality. And of course we're going to square both sides to get rid of the square root. And we will get 2x minus 6 is greater than or equal to 100. Okay, and then after that, let's continue solving. So if I did add 6 to both sides, let me rewrite it up here. You'd get 2x is greater than or equal to 106. And let's now divide both sides by 2. And we get x is greater than or equal to 53. Okay, so that's an answer. And we also need to go back to the inside of the square root and make that to be greater than or equal to 0. So let me zoom in here. Let's make that to be greater than or equal to 0. So we will have 2x minus 6 is greater than or equal to 0, which means that 2x is greater than or equal to 6, which means that x is greater than or equal to 3. So there's another answer right there. So we have our two answers. X is greater than or equal to 3 and x is greater than or equal to 53. So quickly on a number line, let's say 53 is way over here on the positive side and 3 is way over here. It's still on the positive side, but 0 is on this side, obviously. So how about this? Instead of testing values, you could see x is greater than or equal to 3. That's to the right. X is greater than or equal to 53. That's to the right. So let's say I did the greater than or equal to 3 with the red line going this way. And then let's say we did the greater than or equal to 53 with the black line going that way also. You want to represent the overlap piece. The answer will be only x is greater than or equal to 53. That's the only answer because this is the only overlap. Not here, definitely not over here. There's nothing over there. So the answer is x is greater than or equal to 53. You could have done it the other way by testing actual values. Like you could have plugged in 0 right into there. 0, 2 times 0 is 0, minus 6, that's negative. It's imaginary, so you can't do that. So it definitely doesn't work. You could plug in a value between 3 and 53, maybe like 10. I don't know, if you plugged in 10, right? 10, that's 20. 20 minus 6 is 14. The square root of 14 with the calculator is going to be about 3 point something. Take away 4. There's no way that's going to be greater than 6. So that doesn't work either. So you could either do it by representing your areas and the inequality, or you could do it by plugging back in. Jumping to number 16, name the following functions as either exponential growth or decay. Now these are cake, all right? Cake. Now what do I mean by that, cake? An exponential function obviously has to have an exponent that's variable. That's what makes it an exponential function. This is your base, okay? So it's as simple as this if you don't remember. If your base is less than 1, like if it's a fraction that's less than 1 or a decimal that's less than 1, then it's a decay. If it's a value greater than 1, then it's going to be a growth, okay? That simple. I mean, think about it. If you take any number, like let's say 20, and you multiplied it by 3, is it going to grow or is it going to shrink? 3 times 20, it's going to grow. Right? 20 times 3, it's going to grow. It's going to be 60. But if I took 20 and I multiplied it by a value that's less than 1, like maybe 1/2, that's going to shrink. 20 times half is 10. So if your base is greater than 1, it's going to grow. It's going to be a growth function. If your base is less than 1, it's going to be a decay function. Now, don't get confused with the negative sign. If you have a negative sign out here in the front, that doesn't make this a growth or a decay function. That negative sign just talks about the reflection on the x-axis. So if there's a negative sign, ignore the negative sign, just focus in on the base. Actually, anything that's out here, it doesn't really matter. Only the base matters. So what is this one? It's a growth. All right, how about this next one over here? That one? Oh, that's a fraction. It's a decay, right? Wrong. It's not a decay. Well, but it's a fraction. Yeah, but what is that fraction really? 3 divided by 2? That's 1.5. That's greater than 1. So what is that? It's a growth function. All right. Remember, if it's greater than 1, it's growth. If it's less than 1, it's a decay. All right, how about this guy over here? Oh, this must be a growth because of the 1025. Wrong, right? Okay, what is this? The base is less than 1. That makes it a decay. That's right. Okay, moving on. What's this guy over here? Is this an exponential growth or a decay function? Tricky. It's a trick question, right? What do I mean by that? What I mean by it's a trick question. This is not even an exponential growth or decay. Why not? Because the variable is not up there in the exponent. So this is neither. It's definitely not a growth function or a decay function because there is no variable in the exponent. Let's see over here. How about this guy? Is this a growth function or a decay function? This is obviously a decay function. Why? Because the base is less than 1. It's 0.9. I hope this helps. Let's move on. Solving the following. This is the next question. Question 17. Okay, solving the following. Now, whenever you have a variable expression as an exponent, a variable expression as an exponent, and you have just a base and just a base, let's see if we could change these bases to become the same base. Now, what do I mean by that? Well, 8 could be rewritten as what number to what power, right? So if we think about it, let's focus in on the 8. Okay, 8 could be rewritten, this 8 right here, I'm going to put it in parentheses, and I'm going to rewrite it as 2 to the 3rd power, okay? And I still have, of course, the negative 2x plus 3 on the outside as an exponent, okay? And then over here, we have the equal sign. And the 32, I'm going to rewrite the 32 as 2 to the 5th power because 2 to the 5th power, 2 times 2 times 2, 5 times gives you 32. So that's 2 to the 5th instead of 32. And of course, we still have as an exponent negative x plus 1. Now, ladies and gentlemen, whenever you have a power to a power, this is a power 3 to a variable expression power. Whenever you have a power to a power, you must distribute 3 times negative 2 and 3 times positive 3. By the way, if you haven't figured it out, once we get these to be the same base, you could eliminate the bases and the powers just come down as regular terms. So I'm going to eliminate that base, eliminate that base. Technically, if somebody asked you why could you cancel those out, it's because you could apply log base 2. But we don't even need to explain that or even show that. The 2's just cancel out, and let's distribute power to a power. 3 times negative 2, that's negative 6, and of course it has an x. 3 times 3, it's going to be a negative 9. And of course the equal sign is going to come straight down, so we have negative 6x minus 9 equals 5 times negative x, that's negative 5x, and 5 times positive 1, that's positive 5. So we have a simple algebra 1 equation now. Let's get the x's to one side. I'm going to move the 5x over, move the 5x over. I'm going to end up with negative 1x, and I might as well do 2 steps in one here. Add 9 to cancel it out, and add 9 over here. That way you'll have negative 1x equals 14, which means that your final answer, when you divide by negative 1, cancels, divide by negative 1, x equals negative 14. That's your final answer for that one. Of course, we have more practice with option B right there, but I'm not going to waste time. I'm just going to move on. We have 1 more minute. Let's see what we could accomplish here. It says, write the following equations in logarithmic form. What we need to remember is that the base of the logarithm is going to be the base of the exponent. So we're going to write log. What's the base up there? The base is 3. So right here, log base 3 of 9 equals 2. It's that simple. You're just rewriting it, right? So I guess if you're totally confused about this and you already know how logarithms work, like let's say I asked you come up with a log that you already know. Like let's say log base 2 of 8 equals what? How do we figure this out? You say 2 to what power gives you 8? Well, 2 to the 3rd power gives you 8. So now that you know that 2 to the third power gives you 8, now it's just a question of rearranging, and you should be able to figure it out from there.